All right, so first agenda is John Howard.
I think this might actually just be my item, so I'll just jump in.
Mm-hmm.
Yeah. All right, here. So let me present here. So hi, I'm Justin from Google, and today we are excited to announce Ambient Mesh, which is a new way to run Istio without sidecars. So as all of you, I'm sure, are well aware, the existing data plane model for Istio is that we deploy a sidecar inside the adjacent to the workload in the pod that the workload shares. And sidecars, they had a lot of benefits from how you used to get some of the features that you get from Mesh. But before, you had to do things like modify the application, link in new libraries. And by just deploying a sidecar, it was a lot less invasive. And while we still think that sidecars are important and they still have their place, they do introduce some complications. So they're pretty invasive. So we, as I mentioned, even though we don't have to modify the application, we still have to modify the workload. We can't just hot insert a workload into the mesh. And the installing, uninstalling, upgrading it are fairly difficult because once we make those changes to the workload, we actually have to restart it if we, even just for a simple upgrade, which in a lot of Kubernetes environments is not a big deal. But if you have a long running application that's stateful, or you're running in a non-Kubernetes environment, that can be pretty disruptive. The fact that the sidecars are doing full L7 processing means that some applications that have broken HTTP implementations will break. So there's a little bit of a concern that, if you install Istio and you haven't tested it before, it may actually break your application. So there's some amount of vetting that needs to be done before Istio with sidecars can be deployed. And then also, it tends to over-provision because you have to handle the worst-case scenario for your application. There's a tendency to handle that worst case by adding lots of CPU and memory, which can then make it so that the resources on the nodes are underutilized because you have these very large reservations. It also requires a lot of fine-tuning from the administrators so that they can control, it's easier just to over provision than it is to figure out exactly how much is needed. So a lot of people will use fairly large defaults just to be safe. So with the Ambient Mesh, we had a few different goals. First, we wanted to be non-disruptive to applications so that it could be hot inserted into the, workloads could be hot inserted into the mesh without modifying the workloads. We wanted to reduce the chance of breaking traffic for the common use case. We wanted to be transparent, require no downtime, and make upgrades trivial. But we're not getting rid of sidecars because, as I mentioned, they still have their place. So we also wanted to maintain compatibility with existing Istio sidecar applications. And so, Ambient's traffic is interoperable with sidecars. And in fact, sidecars can be enabled, on an as-needed basis within the mesh. And so you can mix and match sidecars, traditional sidecars, and Ambient Mesh workloads. And then we wanted to make sure that there was a smooth upgrade for the different features in Ambient. And I haven't really touched on that, but this will make more sense later as we get through the presentation. And then all of this will allow us to create a simple enablement, disablement checkbox so that makes it trivial to add these workloads. So the architecture for Ambient Mesh is that we remove the sidecar And then we split the proxy that was just existing as that single sidecar into two parts. And some of this was looking at how people use Istio and recognizing that there's sort of two things that people need separately. Basically, everybody needs the zero trust secure overlay that MTLS provides. And then not everybody needs the L7 processing, which is the really expensive part and the part that is more likely to break applications. So in Ambient, we separated those two layers. So the secure overlay is implemented on an agent that runs one per node that is shared among all of the workloads that are in the mesh on that particular node. And we call that agent ztunnel. And so ztunnel is deployed as a daemon set on the ambient mesh network. And then its primary responsibility is to handle the MTLS, so doing the authentication and encryption between the ztunnels and we'll talk about in a second, the waypoint proxies, which provide the L7 features. And what we've done is that those ztunnels are limited to L4 processing. We don't do any L7 processing, so it's less likely, or it will not break applications with buggy HTTP implementations, for example. So those ztunnels are strictly limited to L4 policies and L4 telemetry. Then if somebody needs, on a per namespace basis, needs all the full feature set of Istio and they need L7 processing, then we deploy a full Envoy proxy as a regular pod within the network that we call a waypoint proxy. Then for those workloads that are now need the L7 processing, then the ztunnels from everybody else in the mesh that is trying to connect to those workloads that need the L7 processing then get redirected to connect with the secure tunnel to a waypoint proxy. And that waypoint proxy is what handles the L7 policies and telemetry. And then finally, the way that we do all of this tunneling is with a new protocol that we're calling HBone. And I have a little bit more on it later, but basically it's an HTTP connect tunnel that we have where we're standardizing some of the headers. And that's important for not breaking the applications because it doesn't terminate it. And it also allows us to do authentication as we introduce these waypoint proxies. So visually, here's what happens if you install Ambient Mesh. And the first thing that would happen is that these ztunnels would get placed on all of the nodes where Ambient Mesh has been enabled. But when it first runs, nothing happens. But then as workloads get added to the mesh, their traffic just gets all redirected through the ztunnel. So in this case, let's say C1, C2, S1, and S2 are enmeshed. Before, they would have just directly connected to the networking stack and sent out their traffic. Now we take all of that networking traffic and we redirect it through the ztunnel. And then the ztunnel is responsible for figuring out how to get to the next hop, which is either another ztunnel or a proxy, a waypoint proxy, or if it's outside the mesh, connecting to the outside of the mesh. Now, let's say for this, the workloads in the S namespace that they wanted to have L7 authorization policies or load balancing. Then what would happen is we would then spin up this full Envoy as a waypoint proxy that is just a regular pod within the network. And then we would redirect all of the people that want to connect to S to go through that waypoint proxy here in the diagram. So just to summarize, these are the different layers that we're looking at for Ambient Mesh. So first, when a workload gets added to the Ambient Mesh, we do that secure overlay where we connect all of the workloads with HBone MTLS encrypted tunnels. And then we can do all the L4 policies that would normally be done with Istio. So TCP traffic management with TCP routing, security for L4, so things like ports, but then using the identity from the MTLS certificate. And then we can do TCP metrics and logging. But if somebody wants the full features, then on a per namespace basis, that L7 processing can be enabled where we introduce the waypoint proxies. And in that case, you still have the secure overlay, but then we've added all of the traditional L7 processing that is provided through Istio. So just to drive home how the deployment works a little bit more. So in an existing Istio, if you had these two workloads, the this W1 already has the Istio proxy installed, and then let's say we wanted W2 inserted. Then what we would do is we would modify the pod spec for W2, insert some IP table rules, and then restart that pod. But as I mentioned, now this is a W2 prime because we actually had to restart the workload. In Ambient Mesh, it works differently. So let's say that we had the exact same situation where W1 was already part of the mesh, but W2 wasn't. Now, in order to enable it, all we need to do is modify the CNI so that it redirects all of W2's traffic through the Z tunnel. We don't have to make any modifications to W2. And then also, if we want to take it out of the mesh, we can just as easily just stop redirecting the traffic. And so that network CNI becomes quite simple because really all it needs to do is handle that redirection, turning that redirection on or off through the Z tunnel. So I mentioned that we're using HBone. That's an important part of Ambient Mesh, but that work has actually already been upstreamed into Istio to introduce HBone. So the way that we were handling MTLS had a number of issues in the previous ways that Istio handled it. So what would happen is, here we have like port 80, for example. If the C1 is connecting to S1 and then you have the Istio proxies sitting between them, then when C1 connects to 8.1 on port 80, the C1's proxy would recognize that we need to do MTLS upgrade. Then what it would do is it would open a new tunnel with MTLS to S1 and then send the traffic. But that causes a number of issues the way that it was implemented. So the S1's logic becomes fairly complicated because it actually needs to, it doesn't know when it gets traffic on port 80, whether it's SSL encrypted or MTLS encrypted or not. And so we have this very complicated sniffing logic that then determines whether it needs to be treated as an MTLS tunnel or if it's plain text. So that code is fairly complicated. It also breaks some server speaks first protocols like MySQL, because if the server is the first one to speak, then S1 just waits forever waiting to see, get the first bytes of traffic from the client to determine whether it needs to run MTLS or not. So what we're doing in Ambient, and as I mentioned, is also in I think it will be in the 1.15 version of Istio, is switching to HBone. And HBone has actually been in the works for Istio for a number of years. Before being called HBone, it was also referred to as I think BTS, Better Network, or anyway, there was another name for it before. But
Better Transport Protocol or something, or Better Transport Security.
Thank you. Yeah, BTS, Better Transport Security. But now it's being called HBone. And so what we do with HBone is, rather than doing that upgrade, we just open an MTLS connection between the proxies on a single port. In this case, it's 15,001. And we just do HTTP connect within that and open different streams. So all the traffic is shared in that one tunnel between the client and the server. And so it has a number of benefits. First, because it's on a predictable port and we're not doing upgrade, it breaks the server speaks first protocol issues. We have in theory, fewer MTLS handshakes because everything is sharing that one MTLS connection. The server-side proxy becomes much simpler because it doesn't need to do any of that sniffing or hacks that we've added to do metadata exchange. And then it also just makes the network easier to debug and to write network policies because all the traffic is just coming over that one Istio port that it's using. Okay, and Costin's mentioning that he thinks it's 15,008, so I should update these slides with that. Thanks, Costin. And then finally, what it does is it decouples MTLS encryption from the application so that we have a much cleaner separation. So now I'm going to throw it to Lynn, who's going to go through a demo showing how we can turn on Ambient Mesh and then go through the different layers that I mentioned.
All right, thank you so much, Justin. Let's do this demo. Just to save time, I have this pre-recorded. If you guys don't mind that, let me make sure I can share my screen. All right, can you guys see my screen with book info on the left side? And yes? Okay, perfect. Let me start this. So I have my Kubernetes cluster in Google Cloud. I have Istio Ambient profile already installed. Sorry, just clean up a little bit. Yeah, so I have a couple of, I'm just starting the demo now. And let's check out what's installed on my cluster. So it's a GKE, I believe, 2 or 3 nodes cluster, have book info installed. I have the zTunnel component that Justin just mentioned deployed on every single node. And then you can see which node that product page runs, which maps to the zTunnel who is also running on that particular node. So this is without any service mesh. So let's go to the particular node that product page runs and enable TCP dump. So remember Justin just mentioned on the Edgephone port, which is 15008. So we'll capture TCP dump on 15008 along with the book info product page port. I believe it's 1980. So as you see, when the traffic comes in, it's all plain text traffic. Now, the next thing we're going to do is we are going to label the default namespace with ambient. So by doing that, we're effectively adding every single services and pods running in that particular namespace to ambient. So it's just as easy as that. There's no need to do sidecar injection or anything. So now we're going to visit book info again, as you see the refresh, and then going back to the TCP dump. Look, we got mutual TLS encrypted traffic with cryptographic identity between the client and the server. So all the product page and the review rating intercommunication are all mutual TLS encrypted. If you go to the zTunnel log, you can see access log flowing through zTunnel. So essentially what zTunnel does was capture all the inbound and outbound traffics on that particular node for all the pods running on that node. So let's take a look at the certificates managed by a particular zTunnel. I believe this is the one the product page runs. So let's take a look into a particular secret, which is the first certificate we're looking at. So this is a X509 certificate. The SAN is the book info product page. It's only valid for 24 hours. So this looks pretty familiar to you, right? Pretty much same as the certificates, X509 certificate for the sidecar for your services. The next thing we are going to do is apply a layer 4 Rbac policy. So essentially for this policy, we're saying sleep and Istio ingress gateway is allowed to access product page and nobody else is. So now if we go to not sleep and call product page, you can see it actually didn't succeed because the server side just dropped the packages. So that's layer 4. Now, if you're ready for some layer 7 functions, the first thing you need to do is to deploy a waypoint proxy that Justin was just mentioned. So you can do that with the Kubernetes Gateway API using a Kubernetes Gateway resource like what I have right now, and then just deploy that to your Kubernetes cluster. So I'm standing up a waypoint proxy for product page, and the result of that, you can see the waypoint proxy is up running. And then let's go ahead and apply a layer 7 Rbac policy. And in this policy, we are saying, not only just allow the sleep and Istio ingress gateway, we are also only allow the get method, and nothing else should be allowed. So let's apply that policy to my cluster. And then we're going to try to call from sleep to product page. Guess what? We got access denied, right? So who is denying the access for us? If you look into the access log for the waypoint proxy for product page, you can see the 403 request. When the deletes comes in, the waypoint proxy automatically declines the request with Rbac access IO. You can also get the same layer 7 metrics as today by hitting on the permissions endpoint. So the 403 error we just got is also as a metrics in the Istio request total. Now, if you are not ready for ambient, there's no problem. You can simply label your namespace to opt out of ambient, and then you can also delete the waypoint proxy and any other policies you have. But the problem, I guess, you go back to, without service mesh, you are getting plain text traffic among all your services of booking flow. So that concludes the end of the demo. Essentially shows you how you can add your services into ambient, how you can leverage layer 4 functionalities with the secure overlay, and then how you can leverage layer 7 functionality with the waypoint proxy. I guess we are opening up for questions.
Well,
now
actually, I have a
point.
summary slide, and then we can.
Okay, go ahead.
All right, so present. Great, and thanks for the demo, Lynn. Okay, and so just wanted to summarize the key takeaways from this announcement. So we actually believe that going forward, Ambient Mesh is going to be the best fit for most users. But sidecars are still important. They have their place, and we will continue to support them. And here we have listed a few different reasons that that people might continue to use sidecars. Particularly like if you need dedicated resources, tight customizations that you need to make, or you've already gone through a process of vetting the security model of sidecars, and that's just what people are more concerned about. But the key thing is that ambient and sidecars can be deployed together, and they interoperate as well. So today, in about half an hour, we are going to make this announcement public. The experimental code is going to be available in a Istio experimental branch. And the announcements, we have a couple of blogs, one being the announcement itself. There's a security deep dive blog, and Lynn has put together some, and Lynn and John have put some instructions together so that you can try it out for yourself with some pre-built binaries. And so the plan is that we will release a final version of this pulled into the master branch by the end of the year. So the code is all there. It all works. There's still work that needs to be done though. So please jump in and contribute. We'd love to have people contribute code or comments, or just let us know what you think. And with that, that is all that I had. So yeah, we're open to questions. Stuart?
Yeah, so I noticed when you were talking about the level 7 stuff and the authorization authentication policies, that you were saying that those required that you provision the waypoint proxy using the gateway API. Does that mean that at this, or like with Ambient, the only way that you can put in those authorization policies is going to be at the edge? So that there's no way to put authorization policies for internal or things internal to the mesh, or am I just misunderstanding the way that that works?
Yeah, I'll take that one. In pre-ambient land, gateways are only at the edge. But one way to think of ambient is we're treating gateway objects. Waypoints are essentially gateways for a namespace. So all east-west traffic within the namespace, all east-west traffic within the mesh, if a namespace has a waypoint proxy, all east-west traffic will go through that waypoint proxy. So that's a pretty big shift. It's essentially gateways all the way down in this architecture versus the sidecar architecture.
We use the gateway API to deploy it, but you can continue to use the Istio APIs to configure them.
Yeah, you can continue to use the virtual service API. You can use the gateway API. It's sort of agnostic to the actual API you're using. But the point is that you have an Envoy proxy that looks like a gateway that's sitting in front of your namespace, which is a different model than we had before.
John, you're muted.
You're still muted, John.
We can't hear you, John.
Okay.
Okay, I was just going to add, Stuart, if you remember in the demo, we used the gateway resource to stand up a waypoint proxy for product page. So you could do that for any other service account you like. So you could do that for review, you could do that for rating. So yeah, so it's not directly connect to the east-west gateway or the ingress gateway today.
Okay, so I guess the difference in implementation here is that rather than have a single proxy per like container that is serving a particular thing, we have now just kind of the one point of ingress, which is going to be that gateway. Related to that, what about when you start hitting scalability limits of that Envoy that stood up the waypoint proxy? Will this auto scale up and load balance across them?
Yep.
You're just trying to figure out the mechanics of this.
Yeah, it's not literally one Envoy instance. We talk about it that way because it's easier to talk about it, but it'll just be a kind of Kubernetes deployment that can auto scale.
Yeah, okay.
That's one of the nice parts is that it's not tied to the pod. So it could be an auto scaling deployment. If we wanted to, we could run it in a different cluster. We could run it on VMs. We could run it in, wherever we wanted in theory. Today it's implemented as a deployment though that can auto scale.
Well, so just kind of related to that, is this actually going to be a Kubernetes deployment? Like it has a Kubernetes deployment resource attached to it, or are we like, is there a custom controller that's deploying these pods?
Currently, we use a deployment. We've considered the idea of doing it more hands-on, but we haven't had a need so far. So,
okay, I'm just again curious of kind of the mechanics of this. What it will look like when people start deploying it.
One of the nice things too is that it also makes the upgrade story much simpler as well. So if there's a new version of Envoy that comes out, we can stand up the new deployment and then just start redirecting traffic or new flows over to it and cut it over.
Well, I mean, yeah, you can do a rolling restart of just the data plane, or just the envoys for the data plane.
Yeah.
Without having to impact the actual workloads, which is great.
Yeah.
I like this.
Yep. Custom?
One point that was on the slides, but I'm not sure if it was people sufficiently read it. So the new Ambient is fixing some problems like the fact that server first protocols work out of the box and a lot of other behaviors that are completely transparent and you can just start Ambient and it will not break anything, work exactly like before. But that has a small implication that it's slightly different from regular Istio with sidecars where things will break if you have server first and you have to do all kinds of workarounds. So users should expect a bit of incompatibility or difference in behavior between ambient and regular sidecar, including the fact that you need to put L4 policies for workloads, and so some subtle differences will have to be made in deployment and configuration of ambient, which is actually a very good thing because it's an opportunity to fix some of those dark corners of Istio.
Yeah, and some of those things are documented. Ethan had sent out a doc that talks about some of it's a design doc for ambient, and it talks about some of those things that we did. And another example is that no longer is load balancing done on the client side; it's on the server side. So it shouldn't really impact people too much, but it is a different way to think about the way that that Istio works when ambient is deployed. But
For L7.
Sorry?
For L7, for L4, we still.
Oh, yes, sorry, yes, for L7.
And another point I want to make is that as we move ambient to GA and move forward, it is an opportunity to fix some of the problems that we have with some of the other problems that are not in the details document probably, like the destination or sidecars that can be anywhere, and some of the API surfaces that cause problems today, basically. So it's kind of a clean point when you start labeling your namespace with ambient. You're expected to do some reconfiguration and pay some attention, but we can also kind of get rid of the bad behaviors in Istio. So it's part of the switch.
Great. Any other questions?
I mean, I have another one if nobody else has something. I don't want to take up all the time.
Well, I think you're free.
Okay. So my other question was going to be around telemetry. So I'm imagining that there's going to be a change in kind of the telemetry that's available when we switch from L7 to L4. Or just like, if people aren't taking advantage of the L7, even if it's L7 traffic or like HTTP traffic or whatever, switching over to L4 proxy is going to reduce kind of the fidelity of the metrics. But just because of the change in the deployment model, are we also expecting a change in the type of metrics that will be available as we switch from L7 to L4, or not only just L7 to L4, but just changing like the location of the proxy?
Yeah. The answer is yes. So for example, the latency request, I think, is going to end up looking different because it won't really include the network anymore. So if you want to know the L7, for a request, the metrics around that, it will probably be closer to how long is the backend taking as opposed to what's end to end with the host.
Gotcha.
And I don't know if this is what you were asking exactly, but just to make super clear, on networks that are only secure overlay, so that don't have L7, you won't have L7 telemetry available.
Yeah, I figured that was already the case, but
yeah,
I was just wondering if there was going to be going kind of apples to apples from the L7 perspective. If you've got the L7 proxy in place, how is that changing between sidecar model versus the new waypoint proxy?
Yeah.
I know that like you said, there's going to be change just because the topology means that some of the metrics don't measure the same thing exactly anymore.
Yeah.
But if there's any kind of limitations other than that.
I wouldn't say there's limitations. Like from a user's perspective, ultimately the data that an operator will get will be more or less the same minus modular the latency issues. The way telemetry is exported is pretty profoundly different, right? A lot of our telemetry system makes an assumption that one Envoy proxy is reporting telemetry for exactly one workload, right? And that's no longer the case. So that's going to be a lot of work for like Istio vendors that have UIs to kind of work around.
Right.
But fundamentally, the data that's generated is the same. So ultimately, a user shouldn't care.
If I can add an extra answer here, it's not like we lose L7 telemetry in this mode. Unlike 3 or 4 years ago, now there are plenty of applications. I mean, open telemetry that allow people to natively provide L7 telemetry with a better ground reset, because they see failures, they see a lot of things in. So users who use OpenTelemetry, for example, will still get L7 telemetries, in a standard way, and probably with better quality than what we have today.
Yeah, I guess I definitely agree with what was mentioned earlier. There are tremendous challenges to solve telemetry in this world with multi-tenancy, right, at layer 4 and also layer 7. I guess one thing I would say is we are actually, I didn't show a layer 4 telemetry, but we were really close for the layer 4 telemetry. We don't expect the data user getting would be that much difference, but the source and the target who is reporting the information could potentially be different. The other thing I thought was really interesting to mention is today you kind of have to deploy a sidecar to get telemetry, right? Unless you use eBPF. But with Ambient, you actually get pretty decent telemetry information with just zTunnel, which is super nice, right? Because you got like the source principal, target principal, a lot of useful information regarding major TLS, your source and target workload, and that's all available with just zTunnel without you needing to deploy the waypoint proxy.
All right.
Yeah, I think you have a question.
I have a question on performance. Since we have like single envoy proxy for all the pods in the nodes, so what if like so does it like a single point of failure if a DDoS attack happens or a traffic in bulk comes in the pods? So probably like all the other pods will be affected with that if our envoy proxy will be broken.
Yeah, one of the key parts of the architecture is that we're actually splitting the L4 and the L7. So most of the cost of Istio traditionally is in the L7 processing. It's relatively cheap to just proxy, opaque TCP bits, even over TLS, right? So that's key. We are keeping all of the L7 aspects outside of the Z channels. So that improves a lot there. In many ways, it's similar to like the Linux kernel, right? Linux kernel is a multi-tenant one per node that handles all the TCP traffic on the node, right? So there may be issues that we come up with and address, but I think the architecture is kind of conducive to making this scalable and not have major noisy neighbor issues.
Okay. Cool.
Yeah, and I'll just say this is I just to underline that point. Early in the design of Ambient, we did consider, and there's some other products that do something like this, having something like the zTunnel terminate L7. And we decided not to do it for exactly that reason. We don't think you can do L7 in a like a scalable multi-tenant way. I think the performance of the zTunnel right now is pretty good. And it's something that we're going to put a lot of investment in before getting it to kind of upstream like beta quality. But right now it's kind of comparable in terms of latency to a sidecar running in TCP mode, which is what you'd expect. We think it should be much better than a sidecar running in TCP mode, but it's kind of acceptable right now.
Yeah, and also in the blog that we're announcing has a lot more details about some of the trade-offs and how we ended up here. But we think that the performance, we believe the performance will be better because in general, we'd be able to get rid of one of the L7 processing, because right now there's L7 processing that's happening on both the client and the server side. And now we'll just be doing it once. And network latency is in, clouds tends to be very small. So the benefit of only doing L7 processing once should outweigh the overhead of introducing the network hops of redirecting it through the waypoint proxy.
Cool. Thanks, guys.
Yes.
Yep.
As John explained, so the zTunnel is going to process all the workloads on that space on the node, right? So multi-tenancy is already available, or the noisy neighbor issues and all, or a workload which needs a guaranteed uh, guaranteed isolation should use service mesh?
Well, the way I would think of it is that we're pretty confident that the multi-tenancy, certainly by the time that we upstream this, will be good enough for the vast majority of users. If you need like a strict hardcore isolation between all of your workloads, you might be a candidate for continuing with sidecars. But because the Z-tunnel is not doing L7 processing, we expect a single Z-tunnel instance to be able to satisfy all of the workloads on a particular node pretty comfortably. So we're not particularly concerned about it. This is experimental code, so before we actually merge it upstream, like we need to do more testing and more optimization, all that sort of stuff. But from an architectural perspective, we feel good about it.
We'll also publish a security blog that will dive into compare of a security perspective from sidecar to sidecarless, right? Because in some scenarios, you may still end up with sidecar if you have strict requirement that it has to be, co-located or running together within the same network namespace as your pod. But we do expect most of the scenario you'll be happy with ambient.
Did that answer your question?
Yes. So just a follow up on that. When we say isolation, like Costin suggested, nodes isolating and also fragmenting the infra for different workloads is probably a concern in that approach. So go ahead. Sorry.
Yeah.
No.
What I was going to say is that. Oh, sorry. Were you going to say something, Costin? Okay. I was just going to say it is possible that you actually do want to do this, but it seems a bit odd to be okay with having a shared node, network card, DNI, kubelet, all these other things that are kind of multi-tenant on a node in Kubernetes that are part of the infrastructure, but then not this Z-tunnel component, which is also part of the network infrastructure. Yeah. It's very possible that you have a use case where that is needed, and in that case, you can use sidecars or node level isolation. But I suspect a lot of the hesitation from folks will be coming from, oh, I used to have it in the sidecar, now it's on the node, rather than like what is already in the environment that I'm trusting as to be multi-tenant.
If I can add a small point here, in the past with sidecar, you kind of had the illusion of having isolation. But with ambient, technically, because the Z proxy is seeing all the traffic, it could enforce, for example, a port gets 1 megabit per second, one application gets 1 gigabit per second. It's not obviously implemented yet, but I think Envoy has some filters and some capabilities to do that, and it's becomes possible to actually isolate at a stronger level at some point.
Louis?
Probably the other thing worth mentioning, right? I mean, if we look at historically, the cost of encrypting network traffic scales linearly with the cost of the traffic itself. And if the CPU cost of the workload is proportional to the amount of network traffic it receives, right, then you get a pretty good approximation of the accounting requirement, right? Like typically you would see encrypting network traffic cost about 5% of your CPU budget. Right, that was certainly the experience in Google when we rolled out encryption fleet-wide in production, and we've been spending years shaving that cost. And it's pretty, like the results seem to show that it's pretty linear with bandwidth, and that it's pretty proportional to the workload CPU. Right, so while the accounting mechanism is not perfect in this example, and Costin talked about some ways to make the accounting fair, we think for the overwhelming majority of cases it won't be relevant, because the percentage overhead is low.
Stuart?
Yeah, this is just kind of possibly a dumb question. When you are using L7, is it still piping the traffic through the Z tunnel in order to get the end-to-end encryption, or is it doing the encryption wrapping like via the actual envoy the same way it does currently?
It always
yeah.
goes through the Z tunnel. Yeah.
Okay, so the Z tunnel is always in the network path, even when you've got the dedicated proxy set up for. Okay.
Yeah.
Because it has to do the encryption and the authentication to the waypoint.
Okay.
And
That
the
makes sense.
reason that's important is because it may run on a different node. We could hypothetically introduce an optimization where, like, if it's on the same node, we somehow skip it. Although I suspect that'll be very tricky to do. But the key is that anytime you're moving across a node, you have to be encrypted. So.
Okay, it's probably not worth. That doesn't seem like it'd be an optimization worth worrying about. I was just kind of curious if whether we're still, or like the Z tunnel was kind of still in the data path.
Yeah, and also keep in mind, like the demo I was showing, right? I didn't deploy a waypoint proxy on my client, right? Because that's not required for the scenario I was using. And most of the cases, you won't need a client waypoint proxy. So in that case, you have to kind of have something to upgrade your traffic. That's the Z tunnel is doing that job too.
Well, okay, so expansion on that thought. If you have kind of a hybrid deployment where you've got sidecars in some places and are using the ambient in others, how does that traffic look like? Would it you basically go through Z tunnel then to the waypoint proxy on one end and then go directly to the sidecar on the other, or like, how would that work out? Or is that
so the way the Z tunnel, it only manages pods in ambient, right? So we have code through the Istio CLI plugin to figure out which pods are part of ambient. So if you recall during the demo, I labeled the namespace default to be part of ambient, so that essentially tell the Istio CLI, hey, every single pod in this default namespace is part of ambient. So you could potentially have a pods in other namespace that's not part of ambient, or you could potentially have pods in the default namespace you want to opt out of ambient. There is a way to do that by putting a special ambient, I think it's ambient mode long label on. So essentially, the Istio CLI knows which pods they need to configure redirect of traffic for all the inbound and outbound traffic for all the co-located pods that are part of the ambient on that particular node they are managing. So it essentially would not do anything if you have pods with sidecar on that node the Z tunnel is managing.
Makes sense.
Yeah, and also back to what Justin was mentioned. So John added the Edgebone support in Istio upstream. I think it's in master now, right now, not in 1.5 yet. So that enables the sidecar to be able to speak Edgebone, which Z tunnel can speak. So what's really nice about ambient is you can potentially have traffic interop between sidecar and the pods in ambient. So I don't believe any other service mesh could do that between sidecar to sidecarless. Istio Ambient is the first service mesh that can do the interop with mutual TLS. There's a lot of discussion in the chat. I don't know if anything was bring up. Louis, you had a hand. Okay, Ethan, why don't you go first? Yeah.
I think we covered it in chat. So let's.
Okay.
Well, maybe I'll summarize it just for posterity. So Rob was concerned about Z tunnel crashing and taking out the node, which is fair. One point that I don't think we had made clear is that today, at least, the Z tunnel is implemented by Envoy, so it's a fairly mature piece of software. But it's a trade-off. The Z tunnel, like if you lose Z tunnel, you lose the node. But if you lose kubelet, you lose the node. There's a whole number of things that if you lose the node. So anyway, that's summarizing the chat. I think, was that a fair summary? Okay. This is a question. Go ahead.
Yeah. So maybe so the resource utilization of this Z-tunnel, right? So if since it's multi-tenant, and how do we cost it to different workloads? So is that possible?
So we think that the overhead will be pretty constant. And so we don't, for the L4 traffic, since it's just encryption, just like networking today doesn't really get accounted in that way. We don't separate them for the Z tunnels. However, the waypoint proxies are configured per namespace or service account. And so then the accounting for the heavy stuff, which is the L7 processing, will get associated with the workloads that need it.
One broad point that we can speak to a little bit, one aspect of the architecture is Ambient does a better job of matching the resource utilization to the actual need of the cluster. So with sidecars, you have to kind of provision sidecars for your worst case expected load for that pod. And we found, at least at Google, that there are large numbers of highly underutilized sidecar pods floating around. The hope is that since most of the CPU cost is L7, if you have these auto-scalable waypoints, then workloads that don't need a lot of L7 processing have smaller proxies, and workloads that do need it have more. So Lynn Solo has done a little bit of like kind of preliminary measurements there and saw some promising, pretty significant reductions in the cluster-wide RAM and CPU usage. But we're early. But one of the main motivations for doing this work is actually saving cost, right? Like, why have a bunch of CPU reservations that you're not actually using just in case? So.
Yeah, our initial test actually showed the 75% of saving on resources. That is very significant out of your pocket on what you pay for the CPU and memory. So we'll try to summarize that and share with the community as well.
Yeah, that is true. Utilization will obviously probably will be better. So I was asking to account it to various workloads, right? So maybe since it is less and not doesn't worth accounting it for all the workloads, probably we should consider it as a cluster overhead similar to the kubelet and all other. So okay, that's the sense. Sure.
Yeah, for the Z tunnel, definitely. Yeah, the waypoints you can account to the service account, right? Because waypoints are scoped to service account.
Maybe just another question. If you guys could just brief how the load balancing is going to happen in Ambient. I see it's moving from client side to server side. Where is the service to endpoint resolution happening, and then maybe yeah.
So I would recommend reading. There's a section on this at the end of the doc I linked at the top. But to summarize something that's very hard to summarize, in sidecar-based Istio, the VIP to endpoint resolution happens in the sidecar on the client. In Ambient, the client-side Z-tunnel just decides what is the PEP I'm going to. And then when the traffic of, sorry, not PEP, the waypoint I'm going to, and then the traffic, when it finally gets to the waypoint that's in front of the server, that waypoint decides which specific server backend to send the traffic to. It feels very strange and different from Istio land because we're moving from client side to server side routing. But if you take a step back and just think about how networks are typically built, you've got a bunch of servers and a load balancer in front of it outside of service mesh land. It's much more like that pattern. So anyway, that is a major, extremely subtle, complex topic that we will write multiple blog posts on. But I direct you to the design doc, which can do a better job explaining it than I have in the 2 sentences. And I'll relink it in the chat. Louis?
Please excuse the construction noise in the background. Probably the other thing worth noting about the whole solution, right, is the explicit use of layering, right, which is designed to allow either component to evolve separately. And this is a critical long-term thing for the health of the project, I think. Right? We have, as Ethan mentioned, like the Z tunnel is implemented in Envoy today. It may not be implemented in Envoy tomorrow, right? We may use some other technology to make this go. And we can do that without changing the waypoint, right? Because they're not locked together, right? And right, we have way more degrees of freedom about how the system evolves. Also, by using HBone, right, specifically the encapsulation protocol that we're using for traffic, we expect to actually be able to go through common cloud infrastructure, right? Because right, HBone for TCP is basically WebSocket over HTTP2, right, as defined by the spec today at the IETF. Right, so you could go through Google's load balancer, Amazon's Edge load balancer, right, and that's a pretty big advantage compared to what we were doing before. Right, so this system is a lot more composable in general. In theory, you wouldn't even have to use an Envoy, right? You could have a waypoint proxy that was not an Envoy, as long as it met the specific requirements to interop in the system in general, and that's mostly around the security requirements. So this actually gives a lot more flexibility overall, and that was a really important design and architectural goal from the outset.
John, go ahead.
Lynn, if I had more questions, what should I do? Is there a live stream, perhaps?
Oh yes, so, I'm sorry, everything happens so fast. I just haven't had chance to schedule a live stream. So we will run a live stream in 30 minutes, kind of celebrate, this announcement, and also provides an opportunity for the broader Istio community to ask questions, right? So you guys are the maintainers or contributors of the Istio community. We expect there will be people who are users who might be running Istio in production or in their staging environment who may have questions. So that would provide an opportunity for them to ask questions. And also, we can pick on contributors' mind what does ambient means to you. So it's just going to be a fun conversation. Definitely invite you guys to join. The blogs are going out, I believe, in a few minutes, John, and then we'll also tweet Istio official account. You will see messages on Slack. I believe John just created the ambient Slack channel, so feel free to ask your questions there too. Anything I missed?
How will the live stream be broadcast, or how will people know how to click on it?
Yeah, so we will send it to the general channel or the announcement channel so people can join. And I need to send you guys the join URL as speakers once I schedule it.
Great.
All right, thank you guys for joining. And this is a really special day, I feel, for the Istio community. So please follow the announcement blog and check out the Get Started guide, and also read the security blog to understand the security complications for you. And then, engage us back on the Ambient channel, join us on the live stream so we can have more discussion on this. And we look forward for everyone's contribution to Ambient as well. Thanks so much, everyone.
Yeah, and it looks like Eric just indicated, looks like it's live. Yep, I see it on there. Great.
All right, great.
Okay, thank you.
And we'll move everybody else that was on the agenda from today to next week.
Already done.
Yeah, and we'll also plan on doing a follow-up. So I imagine most of the folks that were here today talking about Ambient will make ourselves available. But we'll also make sure there's time for other people to talk to.
See
Thank
y'all.
you.
Thank you. Bye.